Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 7 Notes 2. So we're going to be talking about permutations. So permutations are used to determine the number of outcomes, like we did with the fundamental counting principle, but this time it's a little bit more involved. We will be using factorials today, so make sure you understand what those represent. So let's just take a look at kind of the types of problems we're going to be doing. So manager of a coffee shop needs to hire 2 employees, one to work at the counter and one to work at the drive-through window. So let's take a look. So let's say we have the drive-through window. I'm going to do counter versus drive-through window. So we're going to make a list of how you could take Katie, Bob, and Alicia and put them on those jobs. Well, we could have Katie working the counter and then Bob working the drive-through. We could have Katie working the counter and then we could have Alicia working the drive-through. We could have Bobby working the counter and then Katie working, or Alicia, let's do Alicia. We could have Bobby working the counter and then Alicia working the drive-through. We could have Bobby working the counter and then Katie working the drive-through. We also could have Alicia working the counter and Katie working the drive-through, or Alicia working the counter and Bobby working the drive-through. So let's count. We have 1, 2, 3, 4, 5, 6. So there's 6 different ways that the manager could assign them during that coffee shop. Now that was really tedious to make up that list. So there's a way that we can use factorials to just calculate that out using somewhat of a formula. So let's start by talking about permutations. A permutation is to look at arrangements when a groups of objects are arranged in a certain order. So the order in which we place them matters. Okay, so that's what we're taking a look at first. So here's the biggest thing, is that order is important. So when we looked at our coffee shop, Alicia working the drive-through and Bobby working the counter is different than Alicia working the drive-through and Bobby working the counter. It's when they flip-flop, it's a different scenario. So that's the biggest part about permutations, is that the order does matter. So let's go ahead and let's take a look at permutations. How many different arrangements are there for the word triangle? So this is actually just a play on what we did yesterday. So the first thing I want to do is calculate out how many letters I have. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 letters. So when I'm going to go to set that up, I'm going to draw that out. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 words, or 8 ways, spots for arranging the word triangle. Well, when I start at the first blank, I have 8 choices of letters. Then when I choose a letter, I only have 7, and then I have 6, and then I have 5, and then 4, and then 3, and then 2, and then 1. So this problem, really, just like we learned about yesterday, is just 8 factorial when you finish it all up. So then in my calculator, I'm going to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply all of that out, you end up getting 40,320 different ways to arrange the word triangle for number 2 here. So then, next we're going to take a look at number 3. So now on number 3, we're going to be doing the word triangle, but the first letter has to be a K. So what we're going to do now is we are going to say, okay, we still have 8 letters. And when we have 8 letters, now we're saying this first one has to be not a K, an A. Woo, geez. Okay, this first one has to be an A. So since it has to be an A, there's only one way that that can be an A. And now we're saying, hey, this one is an A. So then when we go to this next one, we only have 7 choices because we know that first one is an A. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we're going to multiply our way down on that one. So 7 times 6 times 5 times 4 times 3 times 2 times 1. And then when you multiply all of that out, it's basically the same as 7 factorial, which is 5,040 ways. So 5,040 ways that we can do the word triangle if the first letter has to be A. Okay? So now, once I can get this to advance, we're going to take a look at number 4. So for number 4, what we're going to do is we're going to try and calculate how many different license plates there are. So to figure out how many different license plates there are, they're made up of 6 characters, 3 letters and 3 numbers. So we're going to assume that our letters come first and our numbers come second. So we have 3 letters and 3 numbers. So first thing I need to ask myself is how many letters are in the alphabet? And there are 26. So I have 26 times 26 times 26. And then how many numbers are there? Well, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's actually 10 actual digits that we can use. And we can repeat numbers. That's why it's not going down. Your letter could be AAA or it could be BBB and 643 and then 644. Okay, so we can repeat numbers and letters. That's why it's not going down. So we're going to do 26 times 26 times 26 times 10 times 10 times 10. And when you multiply that out, you get 17,576,000 different ways. So that's how many different license plates the state of Minnesota can make. Okay, so that's how many different cars and vehicles they can have with those license plates. So let's next take a look at this permutation formula because that's what our note sheet's about. So I'm sure you're all very curious as to what a permutation formula is. So N represents your total number of objects. R represents the number of those objects that you're actually using. So if I say there's 7 people but you're only going to use 4 of them, 7 is your N, 4 is your R. N is always bigger. N is always bigger. So then the formula is NPR is equal to N factorial. Now remember what factorial means based off of our previous note sheet. And then N minus R. So first you're going to subtract it, and then you'll take the factorial of the difference once you've subtracted it. So let's just take a look at some straightforward calculation problems. So for number 5, evaluate 5p3. So 5 is the total. So on the top, we're going to have 5 factorial. And then on the bottom, we're going to have 5 minus 3 factorial. So then let's go ahead and let's simplify that out one more step. So then on top, we have 5 factorial. And then 5 minus 3 factorial is 2 factorial. I'm just going to give this a second to catch up with me here. And on the bottom, we have 2 factorial. So then on top, I'm going to have 5 times 4 times 3 times 2 times 1. And then on the bottom, I'm going to have 2 times 1. So I like to make this easy for myself. So what I'm going to do is I'm going to go ahead and cross off what I can. So I notice that I have 2 times 1 on the top and on the bottom. So I'm going to go ahead and I'm going to cross off each of those. And then I just have 5 times 4 times 3. And when you multiply 5 times 4 times 3, then you get 60. So the answer to 5p3 is 60. Let's take a look at 7p2. So on top, we're going to have 7 factorial. Then on the bottom, 7 minus 2 factorial. So then on top, it's going to remain 7 factorial. And then on the bottom, I'm going to actually subtract 7 minus 2 to get 5 factorial. You always want to make sure that you subtract before you take the factorial. So then when I write out the factorial, on top, I have 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on the bottom, I have 5 times 4 times 3 times 2 times 1. So again, I like to go through the process of actually crossing it off and simplifying. So what I'm going to do is I'm going to cross off everything from 5 on down on the top and the bottom. So I'm going to cross out 5. I'm going to cross off 4. I'm going to cross off 3. I'm going to cross off 2. And I'm going to cross off 1. And then left on top, I just have 7 times 6. So 7 times 6 is going to give me 42. So 7p2 is 42. Next, let's go ahead and let's take a look at number 7. So now we're going to start on some word problems. There are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? Well, think of it this way. For this, order matters, okay? Bronze is definitely different than gold. So we have 10 finalists, but we can only put 3 into an order. 10 is my total, 3 is the number that I'm picking. So now I can go ahead and put that in an order. So I'm going to have 10 factorial divided by 10 minus 3 factorial. So again, I want to go through the work of actually subtracting that out. So then I get 10 factorial divided by 7 factorial. So now that you're kind of starting to get the hang of this permutation formula, maybe you can start thinking of it logically. We have 10 factorial divided by 7 factorial. So save yourself some work. If you think about it, everything, 7, 6, 5, 4, 3, 2, 1, everything from 7 on down is taken care of with this factorial right here. So think logically, what's left on top? Well, that's just going to be 10 times 9 times 8. If you need to go back and do it the old way where you write it all out and cross it off, feel free. But try to think about it logically. And then you end up getting 720. And I want to label it ways because we're talking about a word problem. We're talking about the number of different ways that they can finish. And that's 720 different ways. Okay, so let's take a look at this next problem. So for number 8 here, now we're talking about 9 reporters available to cover 4 different stories. So if I assign Shirley to a story about giraffes and I assign Jason to a story about tigers, if Shirley now covers tigers and Jason now covers giraffes, that's a different scenario. So in this case, order does matter. There's 9 of them, and we're going to pick 4 to cover stories. Again, the order does matter. So then on top, we're going to have 9 factorial, and then on the bottom, we're going to have 9 minus 4 factorial. So then we're going to actually do the subtraction first. 9 minus 4 is 5, so I have 9 factorial divided by 5 factorial. So let's think about it logically. Everything from 5 on down is going to be taken care of in that factorial. So you have 9 factorial on top, 5 factorial on the bottom. So 5 times 4 times 3 times 2 times 1 is all going to be taken care of. So left on top, you're going to have 9 times 8 times 7 times 6. And you're going to stop before 5 because everything from 5 on down is taken care of. So you're going to multiply 9 times 8 times 7 times 6. And when you do that, you get 3,024 ways. So 3,024 ways are the number of ways that you can assign those stories. Next, let's go ahead and let's take a look at number 9. So for number 9, we're talking about Miss Brisky assigning pairs of students. Again, if I assign Jeff and Kathy, that's different than me assigning Jeff and Chris. So here's another case where order matters. There's 5 students, but we're only going to partner up 2 of them. So it's 5P2. So that's 5 factorial divided by 5 minus 2 factorial. So then we're going to go ahead and we're going to simplify that out. We're going to subtract 5 minus 2 before we take the factorial. So then we end up getting 5 factorial divided by 3 factorial. So then 3 times 2 times 1 is all going to be taken care of by that bottom factorial. So all I have left on top is 5 times 4. And 5 times 4 is going to give me 20. So there's 20 different ways that Miss Brisky could assign those partnerships. Okay. Last but not least, I want to take a look at word repetitions. So I want to take a look at when you repeat a word or letters in a word, how that works. So if we have repetitions, then we need to divide by what's being repeated, factorial. So go ahead, pause the video, get this written down. I think this makes a lot more sense when we apply it to an example. So let's take a look at number 10 here. So how many ways can the letters in the word Mississippi be arranged? So the first thing I want to do is count how many letters I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 letters in the word Mississippi. So on top of my fraction, I'm going to have 11 factorial. That goes on the top of my fraction. Then on the bottom, I'm going to divide by anything that's being repeated. So then I have 1, 2, 3, 4 i's. So I'm going to divide by 4 factorial to account for those i's. And then I have 1, 2, 3, 4 s's. So I'm going to divide by 4 factorial to account for those s's. And then I have 2 p's, 1, 2. So then I'm going to divide by 2 factorial to account for all of those p's. So when I punch this in my calculator, I think it's easier just to make the fraction. So on top, I'm going to do in my calculator 11 times 10 times 9 times 8 times 7, all the way down to 1. I'm going to multiply out that entire factorial. And when I do that, I get 39,916,800. And then I'm going to multiply out the bottom in my calculator. So 4 factorial, 4 factorial, 2 factorial. So I'm going to do 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1 times 2 times 1. So I'm going to multiply each of these factorials out separately. And when I do that, I should get 11,152. Pause the video, try that in your calculator, make sure you get it right. And now all I have to do is divide these out. So I'm going to go ahead and divide these two. Then I get 34,650 ways. So that's how many different ways you can arrange the word Mississippi, because it doesn't matter which S is first, because it's going to be an S. It's not going to look any different. So that's why we have to divide by that extra part for the letters. Let's just take a look at one more example. How many ways can the word geometry be arranged? Well, in the word geometry, there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 letters. So that means there's going to be 8 factorial on top. Then on the bottom, we need to account for letters being repeated. Well, that's just going to be the E's. So it's really just being divided by 2 factorial. So this example is a lot more simple than our Mississippi example. So then 8 is going to be cut off because 2 times 1 is going to be taken care of by this denominator. So left on top, you have 8 times 7 times 6 times 5 times 4 times 3. And then you're going to go ahead and you're going to multiply that out in your calculator. When you multiply that out, you end up getting 20,160 ways. And I apologize, my computer is being extremely slow today. So then you end up getting 20,160 ways. So that concludes your note video today. I do want you guys to make sure you get that Schoology quiz taken because it does give you points, okay? So that concludes your note video today, and thanks for listening.